I believe I'm now live. Let's see here. Let's see just in case. Yep, we are now live. So yeah, welcome back to LiveWork, where today we're going to be actually talking about vectors from the problem set of 1802 practice exam 1B. So yeah, let me just go ahead and just find the file first. Um, let's see. Where is the where is the problem set? Is it this one? No. This one I believe. Yep, it is this one. So yeah. So yes, this practice exam has 5 different questions, and I haven't really actually read about this questions, but yeah, let's actually just go straight into the problem. Um, okay, here we go. Let's place this first thing here. Place. There we go. There we go. Oh wait, actually, let me just check, just in case. Okay, it's fine. Wait, first. I hope this is better. Yep, this is much more better. So yeah, let's go and just solve this problem first. Okay. Problem 1. Let P, Q, and R be the points at 1 on the x-axis, 2 on the y-axis, and 3 on the z-axis. Respectively, express QP and QR in terms of I, J, and K. And secondly, find the cosine of the angle PQR. Okay, so we can actually just start. Um, you don't really need to actually to draw things, but yeah, but yeah, I will just draw it for you guys. So we got here the x-axis going this way, y-axis going this way, and the z-axis going to the top there. So it is one. Wait, no, sorry. This one here is point P there, and oh wait, no, I forgot to write the signs there: x, y, and z. So so that's P, and then this one here would be Q, and then third block, I believe it's right around there, that's R. Express Q vector QP and QR in terms of I, J, and K. Okay, so yeah, probably your first intuition is to try to find what is OP, and then try to find what's OQ, and try to find what's OR, and then just do R minus Q to get the vector. Because like yeah, that's basically how you actually try to find different vectors. But yeah, in this case you don't really actually need to know, because we can actually just write this as P here. P, or yeah, you could just write this as OP. Vector OP here is actually point 1 on the x-axis, but nothing else. On the y and z axis it doesn't have any coordinates. No, sorry, I mean the coordinate is 0. So that's for vector OP. For OQ, the position vector would be pretty similar: 0, 0.2, 0.0. Lastly, for OR, and yeah, by the way, this is how I write vectors. because obviously I don't write two of these and then write this. I just make it a half. Wait. But yeah, it is just something that I use. So yeah, this would be 0.0.3. And yeah, by the way, that yeah, we want to express this in terms of ij and k, but yeah, I am very used to writing this into these brackets here, but yeah, just for reference, first one here is the I, this one here is the J, and this one here is the K. Hat direction. So yeah, so yeah. So OP is I, OQ is 2J, OR is 3K. And so basically, if you don't know that, yeah, when you try to find vector Q to P, that means it's position vector P subtracted by position vector Q. Or you could write it as this way first, vector QO plus vector OP. This would result into, obviously we can just write this as OP minus OQ, something like that. This would equal to, okay, so yeah, let's see here, 1.0. So yeah, basically OP here is I, the Q is 2J, so yeah, I minus 2J, it's I minus 2J. Simple. So I minus 2J. That would be the vector. But yeah, a quicker way is to just actually just to see the points and then just try to figure out how much does it change in the x, y, and z axis. In this case, we want to figure out how much is the change from point Q to point P. Well, yeah, when you just look at this guy here, you need to go 1 unit towards the x-axis and then minus 2 units on the y-axis and then 0 units on the z direction. So that's how you could actually solve this thing as well. And yeah, so this is QP and then the second one is for QR, vector QR. There we go. Solving this thing, you can use the same thing. So yeah, it's OR minus OQ. But yes, for me, I normally actually just find the difference straight away. It is 0, it's 0, negative 2, 3. So it's minus 2J hat K plus 3K hat. Because like yeah. But yeah, this is how you write it in I, J, and K. So yeah, this thing is worth 6 points. So yeah, pretty good when you just actually figured this out. And then, okay, so yeah, this is only part A. Part B is to find the angle, find the cosine of the angle, PQR. All you need to do is to find the cosine, but yeah, obviously, you don't want to use your what you call it, your protractor to measure this thing, because like yeah, you could do it a better way, I believe, but yeah, I should say that yeah, it is the method that you use to find the angle between two different vectors. It is by using dot products. So yeah, here is the theory. A dot B here is the length of vector A. There. Multiply this by the length of vector B. Multiply this by the cosine of theta. And this will result into a scalar. So yeah, vector dot vector would equal to a scalar. So yeah, when you have A here, vector A, and then you have another vector here. Let's call this vector b. This guy here is the theta, and so yeah, all you need to do is to just figure this entire thing out. But yeah, we only need to try to find what is the cosine theta here. So yeah, we could write this formula as cosine theta there equal to the a dot b, which in this case you could put any of these into the b or the a, because it is I, I don't know what type of rule is that? Is that called associative? I forgot about the about the name, but yeah, basically a dot b is is the same as b dot a. So yeah, you don't need to worry about the order in this case. When we are talking about cross products, make sure to remember this order. So let's go and write this guy as qp first. Qp dot qr there divided by the length, because like yeah, we want to divide both sides by the length. So yeah, j- just just to make it into the form of cosine theta equals. So yeah, this will be the length of qp multiply this by the length of qr. Okay, so yeah, first things that you want to actually to know is that how do you actually compute dot products? Well, yeah, it's basically the sum of each of the each of those I don't know what each of the parameter, I believe it's called, but yeah. So yeah, basically um we will just be doing this with what with qp and qr straight away. So yeah, so yeah, for qp it's 1 minus 2 0, that's the vector. And then for qr it's 0 minus 2 3. Okay, what you want to do is to just to multiply the one for the x-axis, add it by the product of the y-axis, add it by the product on the z-axis. Do you understand what I mean? I hope you do. So yeah, basically in here, for example here, qp here is in the x-axis, it's 1, because like yeah, I hat represents the x-axis. So yeah, that would be 1. Okay, 1 multiply that by, in qr we don't have any I hat, which means that the I hat here is 0. So yeah, it's 1 times 0, that's 0. Okay, so that's 1 times 0. You add it by the by the j perimeter. No, I don't know. I don't know what's I don't know what's the name is, but yeah. So yeah, it's the x1, and then you multiply by the y's, which is minus 2. You can see here minus 2, multiply this by minus 2, because those two are for the y-axis. So yeah, let's go and write this guy down perfectly, something like that. There you go. Add it by the z-axis, which is for the k, which is 0. Multiply that by 3. Divide it all by the length of the vector. How how do you calculate the length of the vector? It is it is a pretty simple thing. You just need to take the square root of the length in the x-axis, which in this case for qp it's 1 squared. Okay, you add it by minus 2, negative 2 here, squared. It comes from the y-axis. You add it by 0 squared, which is the one for the z-axis, which there is nothing. So yeah, you just need to do the same thing for the other one. That's 0 squared plus negative 2 squared plus 3 squared. Okay, so we just need to evaluate this start thing. So yeah, 1 times 0, that's 0. Negative 2 times negative 2, that's 4. And then 0 times 3, that's 0. So yeah, the answer is 4 when you just sum them all up. So yeah, the top side here is 4. And what's the bottom side here? Okay, so 1 squared, that's 1, plus negative 2 squared, that's 4. So 1 plus 4, that's 5, plus 0 squared, which is 0. So yeah, we got here a square root of 5. Good. And then let's evaluate the other side here. Negative 2 times negative 2, that's 4. 3 squared, that's 9. So yeah, in total that's 13. And so you want to try to calculate the bottom side here. We want to simplify the entire thing. Okay, so yeah, we can just go ahead and just write the 4 at the top. We multiply the bottom side here, and remember that when you actually just multiply root with a root, it will always have a root back at the very front. But then yeah, the inside is just simple multiplication. This is a what do you call it? This is something very common. No, sorry. This is something that you really need to know when you're dealing with multiplication of square roots, because like yeah, you'll need it a lot. But yeah, that's that. So this guy here would equal to, let's actually rationalize this starting. So multiply the tops and the bottom by 65. So it's 4 square root of 65. Divide them all by 65. And that's the answer for the cosine theta. So I hope that's pretty clear. Anyways, let's see here. Let's close that. There we go. Okay. So, let's go to the second one. Let's check here. Okay, yep. Sound is still okay. I hope so. So, where's my illustrator? There it is. Let's go to problem 2. Okay. Do we have enough space? Nope. We don't have enough space. So yeah, I will need to add a new page. There we go. Place there we go. Oh, whoops, my bad. Let's shrink that down. There we go. Okay, let's solve this second problem. Okay, let's get started. Okay, problem 2. Let P is the P is the point 1.1.1, Q is 0.3.1, and R is 0.1.4. These are the points in a Cartesian coordinate. So A, find the area of the triangle PQR. Wow. You might be thinking, "Oh wow, that's crazy." First things that we need to do is to find the entire side, and then after that, obviously obviously you cannot use half times base times height, so you'll use the half times a times b times the sine of theta. But how do you calculate sine of theta? Well, you could calculate it using dot products. Pretty useful to get your cosine theta and then just convert them to sine theta. I mean, that's allowed, but but it's gonna take you a long time. So the way that the way that I'm gonna be doing this is using cross products. What are those? So yeah, before that, let's actually just sketch it first. Let's sketch all all of the things here. So we got here point P, it's at this point here, and then we have here Q, and we have here R. And yeah, by the way, this thing is not to scale or not to any type of Cartesian coordinate, because I'm too lazy to draw those X, Y, Z axes. So yeah, I guess this will do, because we are just only sketching some stuff. But yeah, it is not to scale. So first things first, we can actually take from P to Q here, and from P to R here. And what we can do is to actually to draw a parallelogram. And yeah, all we need to do is to figure out the area of this parallelogram, and then we divide it by 2, because this thing is basically two different. No, sorry, this thing is two of the same areas. So yeah, and yeah, basically this thing is also basically almost the same shape, but I believe it's mirrored. No, it's not mirrored. But yeah, but if we actually take the cross product of my sketch here, the result is negative. How do I know that my graph here would state that the thing is negative? But yeah, it is not always true, because obviously that because because when you just see here, when I take the cross product of PQ cross PR, the result is negative, because when I actually point my finger towards PQ and then rotate it. No, sorry. How do you actually explain this? But yeah, basically cross products. So yeah, basically that it could be a positive way. So yeah, basically this is the right hand rule. So yeah, I recommend you guys to actually to learn this about the right hand rule. So yeah, basically point your hand towards PQ and then curl it around until PR. Obviously, this is impossible. So yeah, you need to turn your hand around to form this PQ to PR. But yeah, this thing will result into a downward way. So yeah, that's that. But yeah, for this we don't really need to care about those stuff. We are just gonna be calculating the cross products anyways. So yeah, let's actually just jump straight it. Let's just jump straight into it. I have been talking a lot, and nothing makes sense. So yeah, vector PQ is Q minus P. Let's do that. That's negative 1.2.0. Okay, and then for PR, this would be the vector negative 1.0.3. Okay, so we want to take the cross product of PQ cross PR. And by the way, PQ cross PR is not the same as PR cross PQ. Instead, it's actually PQ cross PR is negative PR cross PQ. So that's something. And yeah, how do you actually calculate cross products? This is how I do it. It is by using matrix. You have I, you have J, and you have K. And then let's put in our vectors here. So yeah, PQ here is the one there, PR is the one there. So you want to take the determinant of this thing. This would equal to, so yeah, we will first do the I here, cross these guys here and calculate this guy. So this is 6, so it's multiply that by 6. There you go. And yeah, how do you actually calculate determinant of a 2 by 2? Simple. Multiply the one going from the top left to the bottom right, subtracted by the one going from the bottom left to the top right. So yeah, that's 6i. So let me just rewrite that. So it's 6i, and then for j, so cross this one out, cross this one out, take the cross product between these two guys here. That would be -3, but yeah, for the j, it would be a plus. So yeah, the sign is a plus, and then it's a minus, and then it's a plus. Oh wait, no, sorry, actually, instead I will just actually write this in a much more friendly way. So I of 2003, I'm so sorry, but yeah, this is something that I need to do. Subtract this by j of the cross product -1 0 -1 3, lastly plus k of the cross product of -1 2 and -1 0. So yeah, basically for the I here, cross this one out, cross this one out, calculate the determinant of this guy. For j, cross this one, find the cross product between those two. And then for k, same thing, but yeah, for j it would be a negative because yeah, the rule is always plus minus plus. So yeah, that's that. So this is how you compute determinants. But yeah, there is also a different way, which is summing this one up, multiply it by this one, multiply that by this one, subtract that by the inverse one. But yeah, that thing, I have used that method, and yeah, it is no fun. So yeah, I recommend just using this one because yeah, it is a much more friendly way. So yeah, let's go and calculate this 2003 matrix. That would be 6. So it's 6i -3. So yeah, that's a plus 3j. And then we got the k here of -1 times 0. Okay, and then subtracted by -2. That's 2. That means so it's plus 2k. And we got a vector. So yeah, basically a vector cross a vector would result into a vector. And by the way, when you just compute this thing here, what you get here is actually a vector normal to PQ and PR, which means that it is actually perpendicular to it. So yeah, when you just check, you can just plug the numbers in. PQ dot P cross PR, that would equal to 0, and then PQ cross PR dot PR would be 0 as well. So that's basically that. So you got your vector here, but what we want is to find the area. We don't want the vector. And actually, this is why we actually use cross products. It is because cross products actually, so yeah, the direction is normal to both of the vectors, but the length is the area of the parallelogram. So let's compute the length here. So the length of PQ cross PR, let's compute that. So using same thing, 6 squared plus 3 squared plus 2 squared. There we go. What you'll get is 36 plus 9, that's 45, plus 4, that's 49. Take the square root, that's 7. And this is the area of the parallelogram. We are not yet finished. So what's the area of this triangle? It's 3.5 or 7/2. So yeah, you just take 50% of this area of the parallelogram. And that's that. Let's go to part B. Find the plane through P, Q, and R represented in the form AX plus BY plus CZ equals to D. Okay, so when you're talking about planes, it would, so yeah, when you have a plane, it would always have a vector normal to that entire plane. And what is that normal vector is something that you can actually calculate it using just take two, like, yeah, take three dots, make vectors, find the cross product, you'll get the normal vector. But that is something that we have already done, because when we make a triangle, we already have those 3 points. So yeah, you can have first vector and 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 also another vector, and then just multiply them together. Just take the cross product and you'll get a vector. And yeah, by the way, this thing could have two different solutions. No, actually more, but yeah. So yeah, the first solution will be positive. The other one could be negative. So yeah, we need to make sure that sign is correct. But yeah, as long as it is a multiple of the equation of the plane, you should be fine. So yeah. This thing here is actually our normal vector that we have already calculated. But now, how do you figure out the plane? Well, basically you take the dot product, I believe. You just take this vector and then just have x, y, z, assuming that that's a point in that plane. So when you take the dot product, the result must equal to something. Is that so? No, x, y, z is a position vector. So yeah, I believe that's that. But yeah, obviously my explanation is wrong. So yeah. All you need to do is to copy paste the 6x plus 3j here. Turn the I into x, turn the j into y, and then turn the k into z. Plus 2z equals to, it's not 0. Disclaimer. How do you compute this? Well, you take one of the points here. You could take p, q, or r, but in this case I would say p would be the easiest. So p is 1.1.1. So put it inside here. 1.1.1, that's 6 plus 3 plus 2, that's 11. And that's the plane. Good. Easy, right? That's how you find the plane. So yeah, last one here. Part C. Is the line through 1.2.3 and 2.2.0 parallel to the plane in part B? Explain why or why not. Well, first things first, we need to think about something. What does it mean when it is parallel to the plane? Well, yeah, let's just try to sketch this. For example, this thing here is a plane. You have a vector here, which is the normal vector, which is perpendicular to the plane. And then you have a line parallel, I believe. No. Would it actually... Oh. Is it parallel or not? So yeah, basically, when you want it to be parallel to the plane, you want to make sure that, yeah, it is not something like this. It is clearly not parallel. But when you make the line to be something like this, for example, which is normal to the normal vector, then that would be the answer. So yeah, we need to find a vector. No, we want to find a line that is perpendicular to a vector. And by the way, a line can be represented as a vector with a time scale. So yeah, you could actually just think about it like that. But yeah, for me, I would say, yeah, let's go and let's just try to find the vector first here. The vector of 1.2.3 and 2.2.0, I will call that as vector v. that would equal to 1, 0, negative 3. 1.0 point negative 3. So yep, that's that. Yep. So that means that when you, okay, so yeah, we have this vector here which points to 1.0 point negative 3. That is basically the direction. And yeah, all we need to care about is the direction. Because like yeah, because like we are going to be comparing this to the normal vector. So yeah, we want this vector here to be if this vector is normal to the normal vector, that means that the line and the plane is perpendicular to each other. So when you just try to check this, 6.3.2 and 1.0 point negative 3 do the dot product, that's 6 times. Okay, so yeah, v vector dot the normal vector there equals to 6 times 1, that's 6, plus 0 times something, obviously that's 0, and then minus 3 times 2 would be minus 6. This thing is 0, which means that v is perpendicular to n, which means that it's perpendicular to the plane. So v is perpendicular, no, is parallel to the plane. And that's the answer. Okay, so yeah, that took me a while. Okay, good. We just need to do another 3 more problems. And we have done this about, I don't know, how long has it been? 30 minutes, good. How long should it take? 1 hour, I believe. But yeah, I'm just explaining this and also writing, so yeah. But yeah, anyway, this is, and yeah, by the way, this practice exam is actually very close to the difficulty of the exam. So yeah, I take this guy so that yeah, you could actually just know, like, how hard is it actually? How hard is it about? Like yeah, it's not perfectly that. So yeah. So let's actually start with the third artboard. And yeah, by the way, the question is only 1 page, but the answer is 5 page. I assume so. There we go. Place. Huh. It's too big, I know. Let's shrink it down. What? Okay, shrink it down. There we go. Okay. Let's start this one. A ladybug is climbing on a Volkswagen bug. What? Equals to VW? Okay. In its starting position, the surface of the VW is represented by the semicircle, by the unit semicircle x squared plus y squared is 1. Y is bigger than equal in the xy plane. The road is represented as the x-axis. At time t, the ladybug starts at the front bumper, 1.0, and walks counterclockwise around the VW at unit speed relative to the VW. At the same time, the VW moves to the right at speed 10. Find the parametric formula for the trajectory of the ladybug and find its position when it reaches the rear bumper. B. Compute the speed of the bug and find where it is largest and smallest. Hence, it is easier to work with the square of the speed. Okay. Um, first things that first thing is that I don't understand anything, but yeah, let's try. Let's have this guy here to be something like that. This is the x-axis, so yeah. Is climbing on a Volkswagen bug. The surface of VW. So yeah, let's say we have this VW something like this. This is 1, this is -1. Okay. And then we got here a ladybug. Okay. Let's do that. We got ladybug there. Pretty accurate, I should say. Oh well. So that's at time 0. And walks counterclockwise at a unit at a unit speed relative to the VW. So I would say that yeah, this bug here actually travels at a constant speed. Um, how do you actually gonna be writing this? Okay, I would say the V of the bug, the velocity of the bug, no, the absolute value. Why? Because like yeah, the speed is always this sorry, the velocity is always changing, but the speed isn't. The speed here is the magnitude of velocity. So yeah, the magnitude of velocity is the same. So yeah, this thing here would be a constant, a big C, I would say. Constant. Constant. There we go. And so, okay. Y is bigger than, yep. Counterclockwise around the VW. At the same time, the VW moves to the right at speed of 10 meters. Speed of 10. So yeah. Well, actually, you could say the V of the VW Volkswagen is 10. That's first thing. But second thing is that this guy here is actually moving 10 I. How do I know? Because like yeah, it is just moving 10 to the right at speed 10. So yeah, you are just moving at speed of 10. Oh, only to the right. So yeah, all of the speed is actually going to the right. So yeah. So yeah, the vector is 10I. Good. And by the way, this is not a physics problem. This is a maths problem. Anyways. So we want to figure this out. Huh. Okay. Okay. What? Find the... Oh no. Wait, no. At a unit speed. At unit speed. Okay. What? So the speed is 1? What? Compute the speed of the... Oh, okay. Okay. So yeah, this thing here is actually a bit much more complicated. So we need to figure this entire thing out. I still cannot think. First thing is that my intuition is gonna be stating that, yeah, try to just check if, no, wait, yeah. If it's actually moving at unit speed relative to the bumper, so yeah. How long does it take for the ladybug to reach the end of the bumper? Huh? That's the question. how long does it take to go to the rear bumper? Well, you know that, yeah, for a circle it's 2 pi r, but yeah, in this case the radius is 1, so yeah, it's 2 pi. That is the radius of, no, sorry, that's the circumference of a circle. But when you're talking about how long does it take to reach the rear bumper, that means that it would be at pi. And yeah, by the way, the speed is actually 1 meters per second, so yeah. It so yeah, it basically states that, yeah, it, it would reach the end bumper when t equals 2 pi. So yeah, when t is pi, it would reach to the end. So yeah, the point will be at negative 1.0. Okay. You could actually relate this to angles. How do I know? I don't know. But yeah. But yeah, in this case, angles is actually better to compute this. But how do you actually represent angles? I forgot. Ah, when you have a certain what's theta? Theta is, oh, it's how many parts of the circle. How did, oh wait, why did I forgot? But yeah, I know that, yeah, basically theta and t would be the same. So yeah, you would basically state that this guy here is gonna be the thing. So yeah. Um. And yeah, by the way, this thing here is relative to the thing. So yeah, we don't need to draw any free body diagrams. So yeah. And yeah, by the way, I haven't actually done any physics because obviously the physics is so hard. But yeah, I obviously just stay it away. But yeah, I should have actually discussed it here. But yeah. But yeah, I don't know why. Instead, I'm just talking about exams. Focus, okay. So what's the position vector? Okay, we need to have position vectors. This would be VW. That's why it's so hard, because I don't have any position vectors. So yeah, VW here is the Volkswagen, and the L here is for the ladybug. So yeah, we want to express VW here. No, VWL. I know this is not the correct way to write this, but yeah, VWL would equal to what is the vector. So yeah, first things first is that we want to figure out how far it is on the x-axis. So yeah, when you have actual theta there, that means that, yeah, it's basically the adjacent over the hypotenuse, which in this case the hypotenuse is 1. So yeah, it's basically only the cosine theta, as the cosine theta is actually the adjacent. But yeah, you could write this as t. So yeah, simple. We got cosine t. Point the y-axis, which in this case is actually sine t. Okay, good. We figured this out, but yeah, obviously VW is also moving. Oh, okay. Oh, yeah. So I know actually where is actually OVW. Ah, that's better. OVW here is actually 10t point 0. T here is the time, but yeah, obviously we just assume everything is the same. So yeah. How did I get 10t? Well, yeah, basically speed, velocity. So yeah, speed is velocity times time. You know about that. So yeah, I just did that for a constant speed, that is. So yeah, I figured that out. So we want to figure out the parametric equation for the trajectory of the ladybug. So what's OOL here? You just need to add those two up. Oh wait, yeah. So it's 10t plus cosine t point sine t. There you go. And that's actually the parametric equation. So let's just write this in a much more beautiful form. OL equals to 10t plus cosine t sine t. Good. Obviously, I have wasted lots of time. I should just talking. So yeah, that's that. Find this position. Okay, so we figured this out, but we want to try to find at what position is it at the rear bumper. Negative pi. Why are you so confident? I don't know. So yeah, basically, according to my parametric equation, when t is pi, it should be at the end. So yeah. So when you do this, 10 pi here. No, sorry. The position is 10 pi plus cosine of t, which is minus 1. And sine t is actually 0, so yeah, it's 0.0. That's the point. So yeah, that's simple, I guess. Huh. But yeah, I guess that's that. So, okay. We figured that out. Compute the speed of the bug. Okay. We want to try to find the speed. That means that we want to try to find the change. Okay. We want to first try to find the velocity, obviously. We want to try to find the velocity of the real bug. What's that? The velocity of the real bug here is actually, let's go and take the derivative, which is why that we learned derivatives. So yeah, basically, how do you actually calculate derivatives of a vector? Derive the x1 and then just derive the y1, as long as it's some stuff. So yeah, in this case we are going to be deriving this. No, we want to take the derivative over t. So yep, that would be 10t would be 10, cosine t would be minus sine t, point sine t here would be cosine t. Good. And now we just need to figure out what the length of v here is. This would equal to, let's take the square root of 10 minus sine t squared. So that's 100 minus 20 sine t plus sine squared of t plus cosine squared of t. And to figure out where the maximum is, you would obviously try to find the second derivative, or you could actually use a bit of logic. So yeah, first things first, you know that sine squared t plus cosine squared t is 1. This would equal to the square root of 101. Subtracted by 20 sine t. So yeah, according to the tip, it states that just compute the speed squared. But yeah, you can also just see it from here. So yeah, basically when you take the speed squared, you could actually just derive. No, sorry. You could actually take the derivative of 101 minus 20 sine t, which means that it would be negative 20 cosine t, and figuring out where it would be 0 first. So when you actually take it, to be 0, 0, that would be where it would be at the very max. No, sorry, it would be at the relative maximum. What? The relative maximum or the relative minimum. But yeah, obviously you need to take the second derivative just to figure that out. But for me, I would say that yeah, obviously I know that sine t here is basically from 0 to pi. I know about that. Okay, good enough. And so I know what the minimum is. The minimum is would be a 0, but the maximum here I know it would be a 1. And so when you just put in the number, when time is 0, it would be having the high speed of square root of 101. So max would be at t equals to 0 and pi, because basically that yeah, the smaller this thing is, the bigger this thing is. That's the principle. So yeah, when t is 0 and pi, that means that sine t is 0, which is basically at the minimum. Obviously it couldn't be 3 over 2 pi because it is obviously over the moon. Nope. It is over the horizon. No, sorry. It is below the road, so yeah, it's impossible. So yeah, the maximum and the minimum is actually on 0 and pi. Good enough. And what about the minimum? The minimum here would be the place where this thing is the highest. In this case, it's pi over 2. Therefore, we know that the thing would be the thing. So that means that we know that when you put in 1, it would be the square root of 81 or 9 to be the maximum. But where is it? It's when t equals 2 pi over that. Pi over 2. And that's the answer. Okay, pretty good. But yeah, I am so sorry if I explained things a bit weirdly. So yeah, I'm so sorry about that. Problem 4. Okay. Let me just check just in case. Yep. It's still fine. Good, good, good. Okay. Let's do this. Problem. Let's add the new artboard. There we go. File place. There you go. Okay. Problem 4. M is that, okay? Okay. Compute the determinant of M. Well, that would be easy. 12. Wait, how do you know? I cheated. How? Well, basically, this guy here already states that yeah, that's the determinant, but I'm not sure for certain that that's the determinant. Instead, I need to check it again, just in case. So yeah, compute the determinant. So yeah, basically I have told you about trying to find the determinant. So for A here, it would be 1 times the determinant of 2, 1, minus 1, minus 1, subtracted by 2, 3, 1, 2, negative 1. And lastly, plus 3, the determinant of 3, 2, 2, minus 1. There we go. So calculating this, negative 2 plus 1, that's negative 1. Negative 3 minus 2, that's negative 5, so plus 10. And then this one here, negative 3 minus 4, negative 7, negative 21. this would give me negative 12. I knew it. My calculation is totally wrong. So yeah, now find the numbers a and b in the formula for matrix m negative 1, the inverse of m. So actually thinking about this, um, so yeah, m inverse would be 1 over the determinant over the adjoint. Well, how do you calculate adjoints? I will later teach you. But yeah, instead I'm going to be actually doing this a bit of the quicker method. So yeah, it's 1 over 12 of the negative adjoint. Subtract adjoint. There we go. Okay, so first things first. Um, okay, okay. So basically, from a problem like this, you first need to figure out which one you need to try to find, which is a and b here. And yeah, this one here is basically when it is actually transposed. That means that when you actually mirror this would be at here. So you need to figure out what are the values for this point, which in this case you just need to check these two things. So yeah, I will just put dots there. 2, 3. Okay, first things first. You try to figure out the minors. I believe that's, well, actually I don't know what do you call it, but yeah, you first actually figure out what is the value of this 2 box here. So yeah, first things first is the 2 here. So yeah, to calculate what is it at row 1 column 2 is to just to cross these 2 out here, ha, ha, and then take the determinant. Same stuff. So yeah, that will be negative 5. And then for this one, cross negative 3, that's negative 7. You don't need to care about the plus and the minus sign first. Good. Secondly, you want to assign plus minus plus in a checkerboard fashion. Starting from this one here would be a positive. So yeah, this would be dot 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 dot. This would be turned to a positive. This one will be a negative. So yeah, this is a multiplied. It is not okay. The sign must to be that. No, it's actually if you have the sign right over there, you need to flip it, or you don't need to flip it. So that's that. And then lastly, you want to take the transpose, which would be no, sorry. Yep. You want to transform it. No, you want to translate it. So yeah, the one at the top will be turned into the one at the bottom there, something like this. And so this would be your adjoint. But yeah, in this case here, you want to figure out what is the negative adjoint there. So yeah, because like the form is at 1 over 12, so a would be negative 5, b would be 7, as that's your answer. I hope that's clear, but yeah, obviously it's not clear because I know it all. But yeah, I guess that works. I'm so sorry if my explanation is too crazy. I am trying my best to explain this, but yeah, obviously I am more talking about how you will actually need to think for each problem instead of how you actually solve the problem. No, what is the theory behind the problem? So yeah, that's that. C. Find the solution R vector x, y, z as a function of time. Oh, okay. Okay, so for this problem C here, you got here three functions. So yeah, the best way to do this is to make a matrix. 1 2 3 3 2 1 2 minus 1 minus 1, and then you multiply this by x, y, and z. This would equal to function of 0 t3. There you go. So you want to find this. You want to find the x, y, z for this problem here. The way that oh wait, no, actually, oh yeah. So yeah, this thing here is basically the same thing as this guy. So yeah, we can actually use this other guy here to calculate it. So yeah, basically the principle is a dot x would equal to b. That means that x x would equal to a inverse 1 over 12 of the crazy function that we have, 114 negative 5 7 negative 8 7 negative 5 4. 0 t3. Okay, so now we just need to try to figure out this multiplication. So this is a inverse, this is b. So yeah, let's try to figure out how do you actually multiply this thing. And yeah, by the way, you are just taking the dot product of the row to the column. So yeah, it is the okay. So yeah, the result here is this thing here is a 3 by 3. This guy here is a 3 by 1. That means that the result would be a 3 by 1. X, Y, Z would equal to 1 over 12 of this thing here. So yeah, we want to take the mth row or the first row, multiply it by the column. So yeah, you want to take the dot product. So yeah, 1 dot 1 times 0, that's 0. 1 times t, that's t. And then 4 times 3, that's 12. So it's 2 plus 12, t plus 12, sorry. And now let's figure out the second one here. 7t minus 24. Third one here, minus 5t plus 12. Okay, what you have here is, okay, so you can actually write this r vector here as, like, yeah, this thing here is actually compute r vector t over 12 plus 1, 7t over 12 minus 2 minus 5t 5t over 12 plus 1. And I have run out of space, so yeah, I am gonna actually, nope, it doesn't work like that. Okay, let's just add a new artboard then. Oh wait, no, actually this thing, so yeah, this thing here is is our answer, and then we want to figure out what is it. Oh wait, no, actually we can actually do this pretty quickly here. So what's the dr vector over dt? Simple derivatives tells us that this would equal to 1 over 12, 0.7 over 12, -5 over 12. As you know, that's how you actually take derivatives of vectors. Okay, final problem, yay. Problem 5. Place, as this will be our final problem. Oh, I believe that's too far. Okay, problem 5a. Let pt be a point with position vector r vector t. Express the property that pt lies on the plane for x minus 3 y minus 2z equals 6 in vector notation as an equation involving r vector and the normal vector to the plane. What? Lies. Oh, okay. So pt is a point, and it has a position vector rt. Express the property that pt lies on the plane. Okay. Let's go and first actually just write the normal stuffs first. The normal vector here would be 4 minus 3 minus 2. That pt lies. Okay. So we want to have this pt here on on this line. So yeah, we need to okay. So that's the normal vector. Okay. So basically r vector here dot n vector must equal to 0. That is obviously a rule that we need. So when you take the dot product, in the normal vector, which is 4, -3, -2. So yeah. So we know that r dot n is 0. But also, when you put in the values, you must pt lies on the so yeah, that means that that would be the vector. So yeah, r dot n must be perpendicular to each other, obviously. Wait, actually that's that. Okay, good. Part B. Oh yeah, this is actually the answer for A. For B here, by differentiating your answer to A, show that the r vector is perpendicular to the normal vector to the plane. Okay. So first, let's actually go ahead and just um take 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 the derivative bleh, of r vector dot n vector. And by the way, product rules work. That's very good. That means that I can write this as dr vector over dt dot n vector at this by r vector dot dot the derivative of the n vector, which is a constant, so you can write this as 0 vector, would equal to 0, because when you just take the derivative of 0, it would be 0. That means that when you do the entire thing, you notice that dr vector over dt here dot n vector would equal to 0. That means that this guy here is actually perpendicular to each other, and that's the solution. Well, I guess that's the answer. So yeah, thank you very much for you guys who actually struggle on this on stream, because obviously I didn't explain anything. Instead, I talk a lot. So yeah, I need to work that out again. So yeah, thank you very much for watching the stream for some of you guys, and yeah, we will actually be seeing you guys in the next live work.